Hey everyone, have you ever done this? You grab your calculator, you punch in a fraction like, say, 1/3, and the screen just fills up with threes that go on and on and on forever. Kind of weird, right? Well, today, we're going to get to the bottom of it. We're going to figure out exactly why that happens. Let's crack this math mystery together.
All right, so let's jump right in. Check this out. If you take a simple fraction like 1/2, you get 0.5. Nice, clean, simple. It just stops. But then you take 1/3 and you get 0.33333, and it just never ever stops. So what gives? Why does one stop and the other one go on forever? What's the secret? Well, that is exactly what we're here to figure out.
So, here's how we're going to tackle this. We've got a simple 4-step plan. First up, we'll get to know the two basic kinds of decimals. Then, we'll zoom in on those special repeating ones. After that comes the really cool part. We're going to uncover a secret hiding in the bottom of the fraction. And finally, for the grand finale, we'll do a bit of math magic and turn one of those repeating decimals back into a fraction. You ready?
All right, part 1. First things first, we need to understand the two main families of decimals that fractions can turn into. And don't worry, this is super straightforward.
So you can think of it like this. On one team, you've got your finite decimals. The word finite just means it has an end. It finishes. Like 0.5. Boom, done. Then, on the other team, you've got the infinite decimals. And yeah, you guessed it, infinite means they go on forever and ever and ever. They never stop. Just like that 0.333 we were talking about.
So let's look a little closer at a finite decimal. It's just a decimal that has a clear end point. It stops. For example, think about the fraction 3/5. If you do the division, 3 divided by 5, you get exactly 0.6. That's it. It's over. The story's finished. Nice and tidy.
And of course, an infinite decimal is the exact opposite. It's the Energizer Bunny of numbers. It just keeps going and going. Take a look at the fraction 1/7. Go ahead, try it on a calculator. You'll get 0.142857. And if your calculator screen was a mile long, you'd see that whole chunk of numbers, that 142857, would just start all over again and again and again. It never, ever, ever stops.
Okay, let's move on to part 2. So, we know some decimals go on forever. But, and this is where it gets really, really cool, some of these infinite decimals aren't just a jumble of random numbers. Nope, they actually have a pattern. Let's zoom in and take a closer look.
These special ones, the ones with the pattern, have a name. We call them repeating decimals. And it's pretty obvious why, right? They go on forever, sure, but they do it in a super predictable way. They just repeat a certain chunk of numbers over and over and over again. And that little chunk of numbers that repeats? Well, that has a name too. We call it the repeating block. So for our friend 0.333, the repeating block is, just the number 3. Super simple. Okay, what about for 0.545454? What do you think the repeating block is there? You got it. It's 54. The numbers 5 and 4 are like a little team, and they just repeat together forever.
Now, let's be honest. Nobody has time to write numbers that go on forever. So, mathematicians, being clever people, came up with a shortcut. It's a 3-step process. Step 1, you find that repeating block. Step 2, you write the block down just one time. And step 3, to show that this is the part that repeats, you put a little dot over the very first number in the block and another dot over the very last number. That's it.
Okay, let's practice this with a few examples. Take a look at this table. For 0.3333, the repeating block is just 3, so we only need one dot, right on top of the 3. Simple enough. Now for 0.545454, the block is 54. So what do? A dot over the first digit, the 5, and a dot over the last digit, the 4. Perfect. And what about that huge one from 1/7? The block is 142857. To show that whole thing repeats, we don't need a bunch of dots. We just put one over the first number, the 1, and one over the last number, the 7. See? It's a really neat and tidy short. Okay, part 3. Get ready, because this is the moment you've been waiting for. This is the biggest secret of them all. We are about to learn how to predict exactly what kind of decimal fraction we'll make without even touching a calculator. And the entire clue? It's hiding in the bottom number of the fraction, the denominator.
So this is the big question, right? Can we just look at a fraction, any fraction, like 7 over 20 or 5 over 6, and basically predict its future? Can we tell if it's going to be a finite decimal that stops or an infinite one that repeats forever? And the answer is absolutely yes. And like I said, the clue is all in that denominator.
Here's the secret mission, in 3 simple steps. First, and this is important, make sure your fraction is simplified all the way down. Step 2, we focus on that denominator, the bottom number. We need to break it down into what we call its prime factors. Now, that might sound a little scary, but trust me, it's not. Prime factors are just the basic prime numbers, like 2, 3, 5, 7, that multiply together to create your number. And finally, step 3, we just inspect the list of prime factors we found.
And here it is, the moment of truth. This is the secret code. Are you ready? If the prime factors of the denominator are only 2s and 5s, then it's a finite decimal. It will stop. That's it. But if you find any other prime factor hiding in there, I'm talking a 3, a 7, an 11, anything else, then you've got a repeating decimal. It will go on forever. That's it. That's the entire secret.
Okay, talk is cheap, right? Let's test this thing out. Let's look at 7 over 20. The denominator is 20. So what are the prime factors of 20? Well, 20 is 2 times 10, and 10 is 2 times 5. So the factors are 2, 2, and 5. Now let's check our code. Is that list made up of only 2s and 5s? Yes, it is. So our secret code predicts this will be a finite decimal. And if you check, it is. It's 0.35. It stops. Okay, now let's try 5 over 6. The denominator is 6. The prime factors of 6 are 2 and 3. Uh-oh, you see it? There's a 3 in there. That's not a 2 or a 5. So the code predicts this one will repeat forever. And it does. It's 0.83333. See? The secret code works every single time.
All right, time for part 4, our grand finale. We're going to flip this whole thing on its head. We're going to take one of those crazy repeating decimals and see if we can turn it back into a nice, simple fraction. Let's see how it's done.
So for this last trick, we're going to do a little bit of math magic. We're going to take our old buddy, 0.3333, and we're going to prove, once and for all, that it's really just the fraction 1/3 wearing a clever disguise. This is a really cool algebra trick, so watch closely. Okay, let's walk through this nice and slow step by step. Step 1. We need to give our number a name. Let's just call it x. So we'll write down x equals 0.333 ... Easy enough? Step 2. Now look at the repeating block. It's just one digit, the 3. Because it's one digit, we're going to multiply everything by 10. This just scoots the decimal point one spot to the right. So our new line of math says 10x equals 3.333 ... You with me so far? Okay, here comes the magic part. Step 3. We are going to subtract our first equation from our second one. Let's look at the right side of the equal sign first. What's 3.333 ... minus 0.333 ... Well, look, all those repeating 3's just cancel each other out perfectly. All you're left with is a plain old 3. Awesome. Now look at the left side. What's 10x minus x? That's 9x. So now we have a brand new super simple equation. 9x equals 3. And for the final step, we just solve for x. We divide both sides by 9, and we get x equals 3 over 9. And what does 3 over 9 simplify to? You got it, 1/3.
And just like that, we did it. We proved it. That crazy endless number, 0.3333, is exactly the same thing as the simple fraction 1/3. And this is a really big deal because it shows us that any decimal that has a repeating pattern isn't just some messy, weird number. Nope, it's a perfectly rational, normal fraction, just wearing a disguise.
Phew. Okay, let's do a super quick recap of everything we figured out today. We learned that fractions can turn into one of two things: finite decimals that stop, or repeating decimals that go on forever. We learned a cool shortcut with dots to write down those repeating decimals. We cracked the denominator's secret code. If its prime factors are only 2s and 5s, the decimal will stop. And finally, we proved that every single repeating decimal can be turned back into a nice, neat fraction.
So there you have it. You now know one of the biggest secrets in the world of fractions. This whole secret code thing with the denominator, it just opens up a totally new way to look at numbers. It really makes you wonder, doesn't it? What other little secrets and patterns are hiding in math? Just waiting for us to discover them. Thanks so much for hanging out and learning with me today.